We're going to talk about the basic principles of a straightness measurement using an autocollimation system with a reflector. The autocollimation of Taylor-Hobson projects a 0.5 mm pinhole, which is then seen by a camera as a displacement in both the X and the Y axis. That's shown as the blue box in the center top. For this example, we've inverted the Y axis, as the convention we would like to follow is a slope going up away from the collimator should be positive, and using a reflective method it will normally come downwards as a reflection, which is normally negative. So we have inverted the y-axis. The principle is to set a fixed base length, in this example 300 millimeters, and measure the angle at each of these discrete positions. As we go along, you'll see the dot moves, telling us the different angle, and we can plot these afterwards. To calculate the height, we can use a basic knowledge of a triangle, which tells us we know the angle and we know the base, therefore we can calculate the height. And we do this using a basic tangent calculation, which is the opposite divided by the adjacent. In this example, the height divided by the base length, 300 millimeters. To transpose it to calculate the height, we multiply the base length by the tangent of the angle. That allows us to convert the angle into a series of heights along those discrete 300 millimeter base lengths to a total length of 2.1 meters. Here it shows plus or minus 10 micron straightness. You'll notice that data in between these discrete positions is not registered.